Hello and welcome to this RTInsights conversation with myself, Helen Beal and Tristan Spaulding of Acceldata. Today we're going to be talking about data pipelines. Tristan, would you like to tell the audience a little bit more about yourself?
Sure, and thanks so much, Helen. So I'm Tristan Spalding. I'm head of product at Acceldata, where we focus on data observability for the modern data stack and data pipelines running on that. So prior to Acceldata, I was one of the early product managers at DataRobot, really working on these productionizing these machine learning pipelines for some really high stakes applications. And so it's fascinating today, what's out there and some of the challenges, but also some of the opportunities to really make use of this technology to drive new business outcomes.
Amazing. And data is such a big, excuse the pun, topic, isn't it? We've got big data, it's exponentially exploding all of the time. We get all these different things. We've been talking about data warehouses and lakes in the past. Increasingly, I'm hearing people talk about lake houses. We've got data fabric and mesh. So how do all of these things impact people's data environments, and how should they be used to optimize data operations?
Yeah, I mean, I think the growth of so many terms and so many different angles, I think, speaks to two things. One, the importance of data today. So it used to be that there might be, a couple patterns that you follow, whether that's transaction processing or OLAP. But now there's so many different ways to do it. It's so much a part of the lifeblood of organizations that there's a number of different approaches. I think the second part that really comes out is that there's so many tools out there. There's so many options now to optimize this in different ways. And so it's a much more complex choice, especially for those organizations that didn't start their data journey, in 2010, right? For organizations that have been using data, insurance companies, financial companies, all across the board, retail companies been using data for forever. And they have years and years and years of investments in a very complex stack. And so thinking about how you move these things together, I think and how you optimize for the next phase, I think is a huge concern, but also a huge opportunity. So I think, the other aspect that I think comes into this is, all of these terms really provide a different angle on this, but all of them really speak to different skill sets that people are developing. So people that in the past might have done sort of drag and drop ETL pipelines, well, now you can really, recruit and bring on data engineers who write Python code or write Java code or even Scala code. And so I think all of these different terms, are really ways for how do we use that technology that's out there, the skills that are now out there to solve some of these newer problems in a way that's there. So very, I understand where it's tough to sort of make sense. Is this a warehouse? Is it a lake house? Is it a mesh? Is it a fabric? And to some extent, people are putting their own, angles on each of these. But I think what it speaks to is just how important this is and how big the choices are.
Yeah, so it's very complex, isn't it? There's lots of tools, there's lots of concepts, patterns, practices, there's lots of sources of data and different types of data. But what are the components of a modern data supply chain?
Yeah, so I think the first, there's really several here. So I think the first one is that we can't forget about is where the data actually comes from. So the systems and applications and devices even these days that are producing data. And all of this stuff upstream, to the left, if you follow, sort of the typical diagram, that's a really critical component. And oftentimes that's getting streamed from, where it originates into some of the next phases. We'll talk about it. But I think that's a really key piece of this, that sometimes we tend to focus on the last phase, which we'll get to in a second. But those upstream components and the mechanisms that ferry them, quickly or slowly or better or worse, or expensively or cheaply, from where they originate to sort of the warehouse and processing layer, I think those are quite critical. I think the second component that's quite important, and this is where you see a lot of increasing overlap between some of the major players, let's say between Databricks and Snowflake specifically, is kind of a generic, code-centric data wrangling and data processing layer. So something where things aren't quite ready to be queried with SQL or done in reporting ways. You might be doing some more complex pivoting or sort of aggregation or connection between different data sets. And this is something that often people are expressing in Python or Java, and often Spark is used for this, but increasingly Snowpark out of Snowflake is something that also tries to solve this problem. So I think there's this layer where you've got things emitting data, you've got things moving that data at speed. You've got a layer where you're writing code essentially to really structure this. And then you've got, of course, the famous warehouses or the lake houses, and where you draw the line, on this. Increasingly, these companies are kind of blurring the line on this, on whether it's a lake where the data is raw or it's a warehouse where you're querying it. But certainly, there's a huge number of options now for cloud-based data warehouses that really have a lot of the same traits, and some excel in some ways, some in others. But they all have the traits generally of pay-as-you-go pricing, of doing a lot of the optimization and scaling for you behind the scenes. So it's a lot easier to author. And so I think that takes us to the last layer, which at Acceldata we think quite a bit about, which is what's the authoring layer. So someone on top of this, you're working across different systems usually. How are you authoring and orchestrating those transformations? And so in many cases, people are using, one, they have pipelines that might have existed for quite some time, for decades even, in classical ETL tools. Then you have orchestrators like Airflow and Dagster and Prefect, where people are orchestrating these more complex code-based data pipelines. And then, of course, you have tools like dbt that are making it really easy to author a lot of queries. So in one sense, that's great. You can express things a lot faster as an analyst than in the past. On the other hand, from the finance side, you might get a little more curious about, hey, what's going on underneath these? How optimized are these? Things like that. So I think those are all the components that kind of take you from a device to, a data generating system, let's say, which could be a device, could be an application, all the way to I've got data, I know what it's doing, it's out there and it's available. The only last piece I would then throw out there is how is that data being used? And so I think this is one of the things that's quite, that is evolving quite rapidly and offers one of the biggest opportunities that at least that we see in our customer base. And that's where, in the past, you might have had 80% of the workload might be around basically dashboards and reporting in analytics. I think today you now see a growth in two more tracks. Like obviously that's still important, that's still present. But what you start to see now that you didn't necessarily see, 10 years ago, 20 years ago, is the use of machine learning models. So actually you taking this data, and this is something we saw a lot of at DataRobot as well, but you see people taking these models and really applying them to in a competitive situation. So to offer pricing, the right price to a given customer based on their history, to prevent churn. These are operational use cases to forecast demand. Operational use cases where the quality of your model and the quality of your data really makes a huge difference. And so we see that more and more out there. The other thing we see, and this is something that's being facilitated quite a bit by some of the big players here, is data marketplaces. So people actually monetizing the data that they have, as a source of revenue in its own right. And so there's a number of ways to do this. And obviously it introduces its own level of concern, right, around how are we protecting this data? Are we anonymizing it correctly? Can we ensure when something goes out that shouldn't, can we retract it? I think it also introduces some concerns around quality. So in both of these cases, the machine learning case and the data monetization piece, when you're pushing data outside your organization, whether directly or through predictions, now there's a different level of care and a different level of concern that you need. Because when that data is not good, when it's late, when it's broken, when it's incorrect, it's not going to be someone coming down and telling you, hey, can you check this number again? Can you check this dashboard? I think it might be wrong. It's going to be a customer leaving you, for a competition that gets it right. Or someone, there have been some infamous, maybe regulatory cases around this data not being used well as well. So I think those are some of the big, anyway, it's, you can tell from the answer, there's a lot going on in this space, and certainly a lot of elements to keep track of.
Yeah, loads going on. Of course, that's mainly because of the digital transformation. We live in a digital economy now, and data is very much a competitive differentiator, isn't it? As you say, people are building whole companies around the monetization of their data as well. So a lot of compliance and regulation concerns alongside it. And you mentioned kind of cloud-based data warehouses. And of course, the two key drivers of digital transformation really are DevOps and cloud. I want to talk about the cloud piece a little bit more. So when people move their data into a cloud environment, so, outside of their traditional data centers, what changes for them? And, can we do the good and the bad? So what's good about moving and what's dangerous or needs to be looked after carefully?
Yeah, for sure. And this is the big question facing everyone. And I think for one of the challenges that the companies in this situation have is that in many cases, they're fighting against is basically cloud native incumbents or the cloud native challengers that don't have the history of on-premise data warehouses and data platforms, essentially. And so these groups, of course, they started on AWS, they started on GCP, they started on Azure, and they've grown with that. Whereas I think a lot of organizations that are more mature and have a lot more data assets in some ways now face this challenge, of doing the migration itself, which takes years, can take years. And, the difference between that taking 1 year or 2 years and 3 years, I think is critical. So there's a ton that goes in just to that migration process. And kind of, one of the things we help people with is having kind of a foot on both sides. So we have visibility to on-premise, we also have visibility to cloud systems. And so I think that, accelerating that migration is something that's top of mind for a lot of people. But when it comes to cloud data warehouses, I would generalize it to cloud data platforms. Since some of these tools, the Confluence, the Databricks, do a little more than a warehouse does. And, likewise, like Snowflake is starting to expand beyond that. I think the great thing about it, is that it's so much easier to use. I mean, it's just like the computing power available, and then increasingly the amount of abstraction and sort of, serverless behavior that these vendors offer is just amazing. You're able to do so much more, so much faster than in the past. I think the other thing that, is how quickly this is upgraded. So every 2 weeks, these companies are releasing upgrades on really any dimension of this. And you don't need to worry about maintaining that. You don't need to ask central IT to upgrade that. I mean, these are amazing. There's an amazing reduction in friction on top of all of this. And I think, you see, the proof is sort of in people's usage, right? Like you see how quickly the usage of these things grows. That's because it truly is a much better experience for you as basically the person using the data. Now, I think some of the cons, come back to those same elements, right? So I think, moving quickly and generating a lot of workload and not worrying about the details, I think is great from a user experience level, but it also means that, you can sort of quite quickly rack up some pretty significant bills. So we've worked with a company that, had a single query take $270,000 on one of these, I won't name which platform, but on one of the platforms, just because it's not a problem with the platform. It did what it was told. It did what it's supposed to. It's just like the controls weren't there to kill that. And there wasn't a DBA, looking at it in the way there might've been on premise. And there wasn't contention with other jobs in the way there would have been on premise. And so I think, how quickly this stuff can grow, I think is one challenge. I think there's also kind of a negative side to how quickly things improve. And that's that, mastering these systems, staying on top of the latest and using the optimizations is quite difficult to do. I mean, not many people, even if they're Snowflake experts and Databricks experts, like you were an expert 6 months ago, but not many people have extra time to sort of keep on top of all of the changes that are going through basically like the release process and the upgrade process every couple of weeks as this comes out. So I think, kind of that visibility and kind of staying on top of things, I think are a couple new challenges that people have, with the cloud data platforms that they didn't necessarily have before. But I think, so that's a couple. I think the really big one, and this is like, really where we've been going with Acceldata the last, year or so that I've been here. The number one thing that's different about this is really what happens to data reliability. So data reliability, just meaning, is the data correct? Is the data on time? Is it accurate? Is it within range? Like all of these checks, has it drifted? That's a major annoyance on premise, right? Like I don't think there's been many people that say, hey, I love, my data. I know that it's always accurate. It's great. It's easy to maintain. So that problem is still there in the cloud world, but there's a new problem in the cloud world, which is when all of these systems basically have pay as you go pricing. So when you run a query that costs you money, or burns down credits or whatever the abstraction is, it burns it down regardless of whether the data in that query was good or bad. I mean, bad queries cost the same as good ones. I mean, it actually can cost more typically, since, there might be problems that cause you to scan more data or blow up joins and things like that. And so that's new. In the on-premise world, that slows you down because you need to rerun the query. In the cloud world, it slows you down because you need to run the query, and it costs you extra. It multiplies the cost. And so a lot of the things that we try to recommend for our customers are, catch the data upstream, instrument your pipeline so that you're catching the data before it goes through this whole process. And that way you save yourself, not just time and sort of angst around bad data, but actually money that you might have been sort of spending on queries that were ultimately not going to be effective. So I think that's a interesting dynamic that I think people are experiencing now as they move more workloads to cloud data platforms.
Yeah, it's always a bit of a trade-off, isn't there? That all the beauty and joy of the new technology, but some gotchas to watch out for as well. You've mentioned pipelines a couple of times. I want to dig into that a little bit more. So could you describe what a data pipeline looks like, and also who's accountable for it? Who builds it and manages it?
Yeah, so I think, a data pipeline takes data from, usually multiple sources and goes through a sequence of transformations on that data and ultimately loads it in a destination. And so this could be as simple as going from one source to one database with like little transformations to as complex as hundreds or thousands of steps across hundreds or thousands of databases where these things are coming together. So I think classically, like this was the, ETL developer or BI developers role. I think increasingly, like this is the domain of the data engineer for the most part. Is the person who's writing these pipelines and making sure they're running effectively. And I think it's a tough job. I mean, that's a really scarce. Like if you look at sort of hiring numbers, like an open job numbers, like data engineer is one of the like most in demand fields, precisely because this data is critical and it's really, really hard to know to have mastered all of the systems that are involved in each of these data pipelines. So I think that's a person that underneath all of, there's data scientists, there's all this fancy machine learning and things like that, which I love and like we all love, but to get the data from where it started into those models and back out to the real world, like is quite difficult. And that's sort of what a data engineer does.
Perfect. Thank you for clarifying that. I mean, it's such an interesting space, so fast moving. And of course, there's so much treasure to be found within the data as well. So I'm sure the audience is probably pretty keen to be trying out some tools and figuring out what their data pipelines look like. So what sort of advice would you have for listeners about how to get started with data pipelines and cloud environments for data?
Yeah, I think for sure. I mean, I think, there's obviously lots of capabilities, and that many people might have explored, on cloud vendors, things like that. I think at Acceldata, what we really look at is, people that have some significant Snowflake usage or Databricks usage or, some Airflow pipelines. And what we've been doing basically is offering a free trial here where anyone can sign up for several weeks here, connect these sources and just start to understand and monitor what's going on with these pipelines as they come in and with these queries. So which data is actually generating some value here? How much are we spending on some of these? And how do we sort of bend that curve in a way that's going to help us stay within our budgets? So I think, definitely if people haven't been looking at sort of data observability, I think it's a great time to do it, especially if you're, as we look into next year, planning and budgeting, like really having a handle on that, I find is a critical piece for organizations that are really, the champions of these new cloud data platforms.
Wonderful. So head over to your website for that free trial.
Absolutely. Yep.
Acceldata.com, I assume.
Acceldata.io, actually.
.io. Perfect.
We're a startup, so we have the IO on there.
Nice. Good. Well, it's been great talking to you, Tristan. Thanks so much for your time today, and good luck, audience, with your data troubles.